Today we're going to talk about scientific notation. Scientific notation is a method of expressing very small and very large numbers. And as I'm showing you these notes on the screen, I would like you to write them down in your notebook. We're going to give you an example of scientific notation. 6.02 times 10 to the 4th power. There are a couple different parts that are involved with scientific notation, and the first one is a constant. This constant here is 6.02. And to be considered as scientific notation, the constant must be between 1 and 10. 6.02 is a number between 1 and 10. You also have your base 10 along with your exponent. The exponent is going to tell us if the number is a very large number or a very small number. If we have a positive exponent, like we do in this case, 6.02 times 10 to the 4th power, we know that a positive exponent means this is a large number, a really big number. If there is a negative exponent, this is going to be a small number, a number less than 1. So let's go back to our example here, 6.02 times 10 to the 4th power. We know that 10 to the 4th power is the same thing as 10 times 10 times 10 times 10, or 10,000. So 6.02 times 10,000 is 60,200. When you have a positive exponent, what you can do as a shortcut here is to move the decimal to the right, whatever the exponent, that positive exponent says. We can do this because, looking at this example here, get my pen, the decimal place was right here at 6.02. But what we did essentially, times 10 to the 4th power, is we moved that decimal place 4 places to give us 60,200. Let me give you an example of a scientific notation with a negative exponent, meaning this is a small number. 2.1 times 10 to the negative 3rd power. We know that 10 to the negative 3rd power is the same thing as 1 over 10 to the 3rd power. So 2.1 times 1 over 10 to the 3rd power is the same thing as 2.1 divided by 10 to the 3rd power, or 2.1 divided by 10,000. When you take 2.1 and you divide it by 10,000, you get 0.0021. So we can conclude here that with negative exponents, we move the decimal place to the left. And again, let me grab my pen. The decimal place was here at 2.1. What we did is we moved the decimal place 3 places to the left because it was 10 to the negative 3rd power. We have some examples for you. So let's go through these examples. 9.3 times 10 to the 7th power. This is a positive exponent, so it's a large number. I'm going to move my decimal place 7 places to the right. So I'm going to start with my 9.3, and I'm going to move that decimal place 1, 2, 3, 4, 5, 6, 7. My new decimal place is right here. I'm actually going to put in my 0 placeholders. And essentially, I have, let me get my commas in here, 93 million. We can clean that up a little bit, get rid of all my loops. 93 million. This is 9.3 times 10 to the 7th power. I moved that decimal place 7 places to the right. Next example, 3.5 times 10 to the 6th power. I am going to move my decimal place to the right 6 places. This is going to make the number large. So I have 3. There's my first decimal place, moving it to the 5. And then I'm going to follow by 5 zeros. Just to check myself, I have 3.5, 1, 2, 3, 4, 5, 6 places. My decimal place is now here. And if I add in my commas, I have 3,500,000. Alright, let's go to the next practice problem. 3 times 10 to the negative 8th power. We have a negative exponent here, 10 to the negative 8th power. So we need to take this decimal place, which is right here to the right of the 3, and we need to move that decimal place 8 places to the left. I'm actually going to start way over here. So here's my 3, 8 places. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Here's my new decimal place. Disappeared on me. So let me fill in all of these placeholders with zeros. And I have, as my answer, to clean it up a little bit, 0.0000006, 7, 8. Last example, 4.2 times 10 to the negative 5th power. Again, this decimal place is going to go to the left. This is a very small number. So we're going to start here, and we're going to go to 0, 0, 0, 0, 4, 2. Just to check myself here, my decimal place was right here at the 4, and I'm going 1, 2, 3, 4, 5 decimal places to the left to get my answer of 0.000042. Now what I would like for you guys to do is to pause the video and go to page 223, and I want you to practice on the example or the exercises 1 through 20. Okay, hopefully you've had some time to go through and practice what you now know about scientific notation. Here are the answers. I want you to go ahead and pause the video, check all your answers, and because I'm not there, go ahead and talk about any that you have questions about. Now we are going to start talking about adding and subtracting in scientific notation. So you got a note sheet, you picked that up at the beginning of class. What I want you to do right now is I want you to fold the note sheet like so that when you open up where it says multiply, divide, add, and subtract, you can see the notes on the inside of the page. Today we're going to focus on adding and subtracting. So if you can open up your notes and go to the adding section. When you add in scientific notation, gotta get my pen here, the powers of 10 have to match. So you're usually going to have to do a little work to make that happen. The first step that I want you to do is find the power of 10 with the lower exponent. And I want you to change it to match the higher exponent. Once you do that, you can then add the constants together and keep the power of 10. Here's an example. We have 2.5 times 10 to the 3rd power plus 3.7 times 10 to the 5th power. So again, I want you to find the lower exponent, which in this case is the 3, and I want you to change it so that it matches the larger. So we are going to change this to the power of 10. Now to do so, 2.5 times 10 to the 3rd power is the same thing as why that keeps disappearing. 0.025 times 10 to the 5th power. So over here on the side, let me just show you that. 2.5 times 10 to the 3rd power is 2,500. Move that decimal place 3 places to the right. Now, 0.025 to the times 10 to the 5th power, I'm going to move 0.025, I'm going to move that decimal place 5 places. So 1, 2, 3, 4, 5, which is 2,500. So you can see that they match. Now that I have this, they're both to the power of 10, so I can go ahead and bring that power of 10 down. And what I have is let me fix that. I have 0.025 plus 3.7. So 0.025 plus 3.7 will give us 3.725 times 10 to the 5th power. Now subtracting, we are going to do the same thing here. When you subtract, the power of 10s have to match. I want you to find the power of 10 with the lower exponent and change it to match the higher. Okay? By doing that, how to do that, you're going to adjust the constant by moving the decimal left as many places as the power went up. Okay? So in this case, 5.6 times 10 to the 8th minus 4.2 times 10 to the 7th. 10 to the 7th is the lower exponent, and we need to change that so that it matches 10 to the 8th power. So 4.2 times 10 to the 7th is the same thing as 0.42 times 10 to the 8th power. Now that we have the same power, we can go ahead and bring that down. It's 10 to the 8th. And I can subtract my constants. 5.6 minus 0.42. 0.55, did I say 0.56? I meant 5.6. Sorry about that. 5.6 minus 0.42 is going to give us 5.18 times 10 to the 8th power.